In this presentation, you will see how the Internet Protocol, or IP, defines the addressing scheme used on networks that are running Transmission Control Protocol Internet Protocol, or TCP/IP. Every client computer on a network has a Media Access Control, or MAC address. A MAC address is a unique number that each Ethernet network adapter receives when it is manufactured. This would be like assigning a unique number to every house in the world as it is built. If you knew your friend's house number, you could be sure that nobody else in the world would have that number. However, when you want to send a letter to your friend, it will be rather difficult for the postal service to deliver it because the address number carries no clue about what person, what city, or even in what country your friend is located. Postal workers would need to visit a lot of houses to find your friend. This would not be very efficient. To make mail delivery possible, most countries use a system that defines addresses as a hierarchy with the country at the most general level, followed by the city name, street name, the house number on the street, and finally, at the most specific level, the name of the person. On a computer network, relying on the MAC addresses of network devices would also be a very inefficient way to make connections, particularly on large networks. Your client computer would potentially need to query thousands of other computers to find the one that you want. IP describes an addressing system for networks that is similar to postal addresses. A network or subnetwork is assigned a number which is similar to the city and country in a postal address. A range of numbers is used for the hosts in each network, which is similar to the street name and number in a postal address. An IP address is made of 4 groups of numbers called octets, because each one holds an 8-bit number. They are usually referred to by the letters W, X, Y, and Z. The octets can be grouped in different ways, depending on the size of the network that they describe. On a small network with less than 255 client computers, the Z octet can represent the host address for the clients, and the W, X, and Y octets can be used for the network address. A medium-sized network requires more numbers to represent all of its clients, so the Y and Z octets can be grouped together to represent the host, and the W and X octets can represent the network. On a very large network with millions of clients, the X, Y, and Z octets can represent the host, and the W octet can represent the network. Together, the network ID and the host ID make up the IP address. In this example of a small network, the W, X, and Y octets designate a network, and the Z octet designates a host on the network. The address of the network on the lower right side is 192.168.1, and the network on the upper left side has the address 192.168.2. The only difference between the two network addresses is in the Y octet, but that is enough to distinguish them from each other and any other networks. The host addresses of both networks start at 180, but there is no confusion with duplicate IP addresses because, as their network IDs show, they are on separate networks.